Hello Year 12 and welcome to the final episode of Mathematical Mowbray Movies for the trigonometry topic. Congratulations on reaching the end. In this episode we're looking at maths surveys, so here's the first one for us to have a look at. What is your favourite subject? And you could, obviously this student's chosen general mathematics. Which is your preferred maths classroom? This student's chosen no laptops M4 instead of smelly M3. And who's your favourite maths teacher? Unfortunately there wasn't a lot of choice there. Because the survey obviously wasn't quite long enough, but Mrs. Mowbray is the obvious answer there. Of course, when I say we're talking about maths surveys in this episode, that is not the type of survey I mean. I actually mean that we're talking about field surveys or area surveys. So you've actually already looked at one example of a field or area survey when you did the prelim course and looked at offset surveys. So it's a little bit hard to see, I realise. But you looked at field notes like this, that's probably a bit better, field notes like this, and field diagrams like this, and you worked between the two. You used this to draw this and this to work out this and a few calculations. I'm not going to go through it again because you've already done that one. In the HSC course we need to look at another couple of types of surveys, and they are radial surveys. And there's two types, plane table radial surveys and compass radial surveys. So I'm going to go through each of those types. But just briefly, the key difference between the two is the location of the angles, or not the location, but the way that the angles are indicated. You can see in this one, they're indicated around the centre, around the origin marked by the O, whereas on this one, they're marked at the corners of the particular survey. So that's the big difference. So let's get in and have a look at some examples. So I'm just going to imagine that this is my area of land or my field that I want to take the survey of. And I'm doing a plane table radial survey. So the way that this survey works is that I choose a point in the field, somewhere in the middle of the field. So let's just say I choose that point to be here. It doesn't have to be exactly in the middle. And what I do from that point is that I look at the corners of my field or my area. So here's 1 corner, 2, 3 and 4. I'm just going to label them A, B, C and D. And what you do is you measure the distance from each of those corners to the centre, or from the centre to each of those corners. And so you literally get out a tape measure to do that, or whatever, to mark out, or a trundle wheel or whatever to mark out and measure those distances. So let's just say, for example, this distance was 70 metres, this distance might have been 30 metres, this one might have been 20 metres, and this one might have been, I don't know, kind of looks like 30 as well, maybe 35 metres. So that's the first thing, is that you measure out the distances to the different corners of your field. The second thing that you need to do in the plane table radial survey is that you mark on the angles in the centre. So you imagine yourself facing a corner. So we'll use, this is that little guy again, Wolf or whatever we called him. Maybe, yeah, I don't know, Wolf. And we imagine that he's facing one of those corners, and he turns his body so that he faces the other corner, and he measures the angle that he turns through. So starts here, measures the angle that he turns through. In this case, this looks like about 85 degrees or something. Then he starts at that next corner, and he turns through an angle, and again he measures the angle that he turns through. I don't know, this is probably 110. Again, starts at that next corner, facing the corner, and he turns so that he's facing the next one, and he indicates what angle have I turned through. This is probably 70. And then he starts at that last one, and he turns his body around, and he says, how far did I turn to get to that next one? I should actually have worked that out beforehand so that I could make sure these worked, because of course they should add up to 360. 110 and 70, 265, so 360 minus 265. This doesn't look very good, does it, in terms of an angle? Looks like more than 95, but let's just imagine that's all good. So he's turned through 95 degrees to get to back to point A. So this is what we call a plane table radial survey. You mark all of those angles at the centre, at the origin, which we mark with an O. That's quite different to a compass radial survey, which is the other type, where we had the different angles marked at the corners. Again, let's just label these A, B, C and D. I know this pen's a bit hard to see, sorry, but it just means I can get a bit more detail in these diagrams. Again, same thing, you choose a point in the middle of the field somewhere, so it doesn't matter where you choose, you know, point like this. And again, you do the same start. So you measure what the distances are from the centre of the place where you put your little table or whatever to the edges, so or to those corners. So again, let's just say that these, I'm going to mark them with this one so it's not too busy. Let's just say this was 100 metres and this was, I don't know, 60 metres, and this one was 50 metres, and this one was 80 metres. Okay, so same start. The difference here is how you measure the angles for the compass radial survey. So what you do is you imagine the northerly direction, which is always going to be up your page. So the northerly direction, so that's here. And what you do is you indicate the bearing. I know you all love bearings. That looks a little bit hard for you to see, doesn't it? So you indicate that north doesn't look very north for you, sorry. You indicate the bearing of each of the corners from the origin, so from this point O. So you'd stand in the origin, or stand at the origin. So what this means is that I'd stand at the origin and I'd face north, and I would then turn to face A, and I'd see what is the angle that I've turned through to face A. So let's say in this case, it looks like it's made, I don't know, 15 degrees or something. So if I've turned through 15 degrees to face A, I would say that this is 0, 15 degrees. That means it's 15 degrees off north. So 15 degrees off north. Then I'd do the same for B. I'd start by facing north, and I'd say how far do I have to turn through to face B. So if I'm facing north, how far have I, oops, sorry, fell over. How far have I had to turn through to face B? And let's just say that, I don't know, you might have had to turn through something like 120 degrees to face B. So I'd write over here that this is 120 degrees. C, again, I start facing north. In each of these cases, I start facing north because they're all bearings. And I say, how far have I had to turn through in order to face C? So I've turned all the way through that angle there to face C. So, you know, I'd say whatever I, think that's going to be. Let's just say it's 210. So I've turned through 210 degrees to face C. And then I do the same thing for D. Starting at north, what angle do I have to turn through in order to face D? Let's just say it's something like, again, it's hard to know exactly because I haven't done a great diagram, but let's just say that I've had to turn through 300 degrees to face D. So you can see that these are quite different in the way that, that they've been set up. Now I'll just give a quick thing about how you'd work out the angles in this one, because obviously they're not given to you at the centre, so it makes it a bit trickier. I know that this one was 15 degrees off north, so I know that little angle there must be 15 degrees. Now what I do is that I do subtractions all the way around to work out the middle angle. If this one's 120 degrees off north and this one's 15 degrees off north, oops, sorry, you can't see, then the difference between the two is going to be the size of this angle. So this must be 105 degrees. I look at the next one. If all the way around to here is 210, but only around to here was 120, then the difference between those two must be 210 minus 120. So this here must be, and again it doesn't really look like it, does it? But this here must be 90 degrees. Same thing here. If this one's 300 and this one's 210, I say to myself, well, what's the difference between the two that I've had to turn through? Again, this one's going to be 90 degrees. Yeah, sorry about the diagram being so inaccurate. I should put not to scale. And then, of course, I say, and this is the important bit, so the first and the last one are a bit tricky. I say, well, if I was at 300 degrees here, how much more would I need to turn through to reach north? Well, there's 360 degrees all the way around. So I'd need to turn another 60 degrees to face north, which tells me if I know this one's 60 and I know this one's 15, altogether those two will be 75 degrees. So I can work out all these centre angles from the bearings that I'm given at the sides. So you're typically asked 3 types of questions when it comes to these surveys. The first one is that you're asked to work out an angle or a bearing. The second is that you might be asked to work out the area of a section, like this. And the last thing is that you might be asked to work out the length of one of the sides, so something like this. Now, if you're asked to work out an area, you're going to be using that area formula you did in your last video, half AB sine C. Okay? If you're asked to work out this side, you're going to know this angle and you're going to know these 2 measurements, this one and this one. So it's going to be the cosine rule that you're going to use to work out this length. So let's have a go at a couple and see how we go with these. So here's the first one. It says the diagram, and I know it's a little bit hard to see those surveys, sorry. The diagram shows a radial survey of a piece of land. It says Q is southeast of A. So here's the point A, and Q is southeast. So totally south would be from A, totally south would be obviously 180 degrees. So if this is southeast, it's not going to be 90, it's going to be halfway between 180 and 90. So halfway between 180 and 90 would be 135. So it says, what is the bearing of R from A? So first of all, I've got to work out what is, if I know that this is southeast of A, then I know that this part here, and I know it's not the easiest to see, I know that let me move that down a little bit. Is that better? Maybe, yeah. So I know that this part here must be 135 degrees. Okay. Another way of seeing that is that if I know that this was like 90 degrees, my 90 degrees here from north to east, and I know that this bit must be 45 degrees because it's southeast, then I could add the 2 together, 90 plus 45 to get 135. Then of course I was given this bit that was 50. So this question says, what is the bearing of R from A? So it's saying if I'm standing at A, how many degrees do I need to turn? So of R from A, if I'm standing at A, how many degrees do I have to turn so that I'm facing R? So you guys have a go at that question. How many degrees would this little woofy guy have to turn in order to face R? All right, well hopefully you worked it out. If he wants to turn to face this, to face Q, he'd have to turn 135 degrees. And then to turn that last bit, he has to turn that next 50 degrees. So he'd have to turn both of those 2 things together. So he'd need to turn 185 degrees. So that's the bearing of R from A. Okay, let's have a look at the next example. So this says a compass radial survey of the field A, B, C, D has been conducted from O. So that's from the origin at the centre. It says find the size of angle AOB. So find the size of angle AOB. So you can see it's a little bit tricky, but give it a go. Thinking about the fact that this is 21 degrees off north, and this is a little bit shy of north. It's not quite reached 360. So what's this angle here going to be? All right, hopefully you worked it out. So if we worked out that this one was 21 degrees off north, because that's what it says here, so this must have been 21 degrees. And if this is 310 degrees here, I have to think how much more would I have to rotate around to get to 360? So there's obviously a 50 degree rotation there, so that must be, I'd have to rotate from here 50 degrees to get to north. So that's going to be this angle here. So what is the angle AOB? It's going to be these 2 added together. So it would be 50 plus 21. 50 plus 21. So it would be 71 degrees would be angle AOB. Alright, the next question says find the area of the section AOB to the nearest metre squared. So it's asking me to find this area here. AOB, that area there. So give that a go, remembering that it's probably easiest, actually I might just give you the heads up. So redraw that triangle if you're a little bit unsure. It looks like this. You know that this side is 60 metres, you know that this side's 75, and you've just worked out that this angle is 71 degrees. So give that a go, finding the area of that triangle. Hopefully you went all right with that. Hopefully you recognised that you needed to use the area formula. Half, AB sine C. Since you had the angle and the two sides either side of that angle. Again, it doesn't matter which one's A and B, and we know this is our C. So the area there is going to be half of 75 times 60, you can put a times there if you want, times by sine of my angle was 71. So I'd whack that into my calculator. Half of 75 times 60 times sine of 71. So it's going to be 2,127.4, did it say metres? Yeah, square metres, which sounds like a lot. But remember, this is for like big blocks of land, so it's not for like a little shoebox. So you expect these numbers to be quite big for the surveys. Hopefully you got that one right. Okay, last question. I know there's sort of a mix between me giving you a hand and you giving them a go. So this one says, the diagram shows a radial survey of a piece of land. It asks you to calculate the angle theta and hence determine the length of the side AD. So for starters, can you please have a go at calculating that angle theta there? So calculate that angle theta. Good luck with that. All right, let's see how you went. Hopefully you recognise that all the way around, a full rotation around that origin there would have been 360 degrees. You're given all these measurements. So I'd be saying, well, what are those measurements all add up to give? The 130 plus the 80 plus the 40, they add up to give 130 plus 80 plus 40 gives me 250. So then I'd say, okay, well, what must this theta be if it needs to all add up to 360? So you're going to say 360 minus 250, and of course that gives you 110 degrees. So there's my theta, 110 degrees. I just worked out that my theta was 110. Okay, then it says, the second part of the question, hence determine the length of the side AD. So it's asking me to determine this length here. So that's my X now. Again, with all these questions, it can get messy because there's so much written on the survey itself. So you might want to redraw the triangle that you're interested in. You're trying to work out X. You've now worked out that theta is 110 degrees. You know this distance here is 18 metres. You know this distance here is 31 metres. So you're going to need to work out that side. Good luck. How did you go with it? Hopefully you recognise that this has got three sides and one angle, so you're going to need to use the cosine rule. And you're working out a side, so you need to use the form of the rule that has the side as the subject. So you need this form of the rule. And then I just substitute my things in, remembering that these two are opposite each other, so they're my C's. A and B, of course, doesn't matter. A, I've just put as 31, B is 18, and I'm minusing 2 times 31 times 18 times cos of 110. So what's it give me? 31 squared plus 18 squared minus 2 times 31 times 18 times cos 110 gives me 1666.69. Don't read into that number too much. I know some of you do. And so then, of course, I am going to square root that because this gives me c squared and I'm after just c. So I'm going to take the square root of that number. If I could write it, it'd be good, wouldn't it? It must be getting late at night. So the square root of that answer gives me 40.825. So I'm going to round up to 40.83. Yeah, they didn't ask me to the nearest anything, so I'm all good with 40.83, and this of course is going to be in metres. That's a weird M, but it's meant to be metres. So hopefully you went alright with that one. Congratulations on reaching the end of the trigonometry topic. I know you've obviously got your test coming up, so I think you've done really well with this topic, so don't forget to study hard and really give it your best shot to get off to a really great start for the HSC. Well done.